Let's discuss the left and the right endpoint estimation of the area under the curve. First, let's discuss the understanding of summation notation. We're going to be adding 4 terms together in the first example and 4 terms together in the second example. Let's put these terms on a number line. They're identified by their subscripts. First, let's write x sub 0. And the next one after that will be x sub 1. The next will be x sub 2. The next will be x sub 3. And finally, we have x sub 4. Now, in the first example, we are going to add x sub 1, 2, 3, and 4 together. Here's a notation that we use. We start with the index 1 and we go through 1, 2, 3, 4, and we stop when we get to index 4 of the terms x sub I. This expands to x sub 1, because we're starting with subscript 1, plus x sub 2, plus x sub 3, plus x sub 4. Okay, so that gives us a sum of the last 4 terms on the number line. Now let's clean that up so we can go to the next example. In the next example, we want to add x sub 0 through x sub 3. So now we want to add the first 4 terms. You see how this is going to correspond to the left endpoint as opposed to the right endpoint? Well, here's how we do it. We are not changing the index on the summation notation. We still start with I equal 1 and we end with I equal 4. The only thing that's different in the second example is the subscript for the index. Instead of being I like it was in the first example, it's I minus 1. So whenever we get to each term, we're going to let I equal whatever number we're at and then subtract 1. So here's the expanded form. For I equal 1 to 4, we start with x sub 1 minus 1. You see how we let the index equal 1, the index I. And for the second term, we add x sub 2 minus 1. And then we add x sub 3 minus 1. And finally, x sub 4 minus 1. And then we just simplify the indices and we get x sub 0 plus x sub 1 plus x sub 2 plus x sub 3. So the only difference between these two is that the index on the terms changed. The index on the summation notation, that didn't change. Look, that is the same as this one. The i's didn't change there. The only place the indices changed were on the subscript of the terms. Now let's go on to another idea involving left and right endpoint summations. Here we have a curve F. We'll identify it. It's the curve F here and the curve F here. Same curve. And we're going to do a right estimation on the left, a left estimation, which I didn't write here. This is our left endpoint estimation. Left endpoint. And when I say endpoint, I'm referring to the endpoint that we use to determine the length of each of the little rectangles. So here's the first rectangle. I'll identify it 1, and this is 2, and this one is the x minus 1, and the x sub n. X sub n minus 1, and then the x sub n rectangle, and there's infinitely many in between. Okay, so what we're going to do here for the first rectangle, I've blown it up here. This is rectangle 1. And you'll see the width of all of these rectangles on the bottom is delta x. But the height is different for each one. And we determine the height for the right endpoint estimation by using the right upper endpoint. So going from the x-axis, this is the x-axis, up to the height of that endpoint, that is this height, this distance, and that is f of x sub 1. Okay, so that means that the length of this little sample rectangle, rectangle number 1, is the function, the y partner, evaluated at the right endpoint. Now on the other picture, we're estimating with left endpoints. So here's rectangle number 1, rectangle number 2, here's the x-axis. Now we're using the left endpoint to represent the length, and we still have delta x for the width. But where's the height of this between the x-axis and the left endpoint? That is identified over here as f of the x-coordinate x sub 0. That's f of x sub 0. So that's in the picture below. The length is the function evaluated at the left endpoint, which is x sub 0. Now when we add all these together, we get, we're going to use delta x on both of them. We're going to use x sub I on both of them, and nothing's changed at this point. And you'll see we want to expand this, so we have length times width plus length times width of the next rectangle all the way through. And the same thing here. The length times the width of the first rectangle plus the length times the width of the second rectangle, etc. So the delta x, the width hasn't changed. The x sub I, identifying the ith rectangle, is defined by the same expression, x initial plus I times delta x. The only difference in the formulas is that this one has the first length evaluated at x sub I, the function evaluated at x sub I, because that is the right endpoint, while this one has the length evaluating f at the left endpoint, which will be 1 unit before I, so it's x sub I minus 1. And if we look at the expansion of this notation, we have, following this arrow, the area is a limit as the number of rectangles approaches infinity of f of, okay, now we're going to go through this summation notation. We're going to start with I equal 1. So it's f of x sub 1 plus times delta x plus f of x sub 2. And we continue like this until we get all the way to the top index, which is f of x sub n times delta x. While on the other one, we have to start a little different. We have to let the x-coordinate for which we evaluate the function to find the length be I minus 1. So when we start the summation using the same limits, I equal to 1 to n, we start with x sub 1 minus 1 times delta x, f of 2 minus 1 times delta x. And then when we simplify, like we did just earlier, we're going to have 1 minus 1 is x sub 0, and 2 minus 1 is x sub 1, etc. until we end over here at f of x sub n minus 1. And one more thing I want to demonstrate in the next shot in just a moment here. The question is, how would this affect the summation that we did in video 101A? I want you to go back and review 101A. I'm going to show you how to redo the whole problem using the left endpoint. So you look at this and compare it to what we did earlier in the video. Okay, so the x initial is equal to 1, the x final is equal to 2. That's the same as we did in the earlier video, which I call part A. The second item, delta x, is determined the same way. X final minus x initial equals over n is going to be delta x, and that turned out to be 1 over x, just like in the first video. And then step 3, x sub I, we use the same formula, x initial plus I times delta x. We didn't change the I here, we used exactly the same thing and got the same result, 1 plus I over n. Now the only thing that's different is when we get to the left endpoint estimation, we use a formula that has a different index. You'll see that's the only thing that's different. So when we do the summation, we start, I'll show you how we do it. We do the summation of f of 1 plus I minus 1 over n times 1 over n. 1 over n's delta x. And then we just simplify by evaluating this function. Instead of at x, we use 1 plus I minus 1 over n. And we simplify, and this is our answer.